this audio effect that happens, this like chirping that happens
The
every
chirp.
now and again.
The
Yeah.
famous Paul Sutter chirp.
Yep. But it's Zoom. It's an artifact.
It's Zoom.
Yeah.
Does have you ever played with using Discord video chat?
I would like to
piping
do
that
that.
in?
I would like to do that, and I'm trying to push everybody else to do that. But then Fraser was like, "Well, not everybody's going to have a Discord."
No, I don't want to have a Discord. I'll do Discord. You can Discord me.
Okay, let's do that. Can we be friends on Discord, or is that?
Can we be acquaintances? I mean, are there levels here?
No, I wish, I'll let them know. I'll let the devs know. I'll ask them.
We need friends, acquaintances,
right?
Randos,
Right. I agree.
Strangers.
Mm-hmm. Yeah, not just friends. I feel like friends is misleading.
It's a bit much.
We're
not there yet.
You still have the boxes.
Of course, I still have tons of boxes because I have tons of telescopes.
Did you give any away to your Patreon people yet?
No, I haven't. And in fact, Patreon doesn't let me do giveaways.
What?
I got a stern warning. It's against the terms of service. I'm not allowed to do raffles.
Why?
Yeah, it's super lame.
But these aren't like pictures. These aren't like selfies of Dr. Paul that you're giving away. These are telescopes.
Physical objects.
Yeah.
Of great import and significance. No raffles. No raffles. So these are all going to Skynet.
Really? Are you sure? Because you're also paying for... So guys, he has a Patreon if you want to contribute, because he is paying for the shipping of these.
I kind of am, yes.
Yeah.
I'll send you the invoice, though.
Please do. I'm actually thinking you maybe should, and I'm kind of serious about that.
Nah, it's cool. Don't worry about it.
So we can do a giveaway then. We could do it in the last, 5 minutes if that's...
We'll do a giveaway at the last 5 minutes, but you need to sign up for my Patreon.
Yeah, and he has it.
There are no consequences for not doing it except for my disappointment.
And thank you, AQ, for doing that. Yeah, here's his Patreon. I'm spamming it. Look at that. Do you see that?
Do it.
It's spammed. Yeah, let's pitch in. Yeah, because this is first and foremost something super nice that he's doing. But yeah, we can subs in here. You can win a telescope today. One of the Galileo
so if
ones.
you're a Patreon subscriber from me, you get complete knowledge of time and space. If you're a sub of Skylias, you get a telescope. I'm not good at selling things, am I?
How's his volume, guys, compared to mine? It looks like it's pretty level. But how are you doing? How is the dental surgery stuff healing?
The adventure, it's getting better. It's getting better. I think I'm sounding better.
Yeah.
A little bit more normal.
Yeah.
The roof of my mouth is no longer on fire.
Good.
Constantly.
It's good.
I'm slowly starting to eat more normal food in a normal human way.
Not fearing pizza?
Not fearing pizza and not cutting everything up into tiny little bits and then only chewing with the left side of my mouth. It's starting to become normal.
Oh, man. If you guys missed it, I did put it up on YouTube. What did we call you? We called you Gold Chain. Gold Chain. Dr. Paul. Is he on Twitch? He's mostly on YouTube. If you guys do the Paul, right there, you can find him all over.
There's
Ask
my
Spaceman.
stuff.
Yeah, and he's been on How the Universe Works. We watched a few of those while you were away, and we were laughing. Mm-hmm. You looked so polished, and a few people were like, "I need to know the makeup," and I said, "Well, we can break that down another time."
I'll break it down right now. It was CoverGirl Ready Set Gorgeous.
Perfect.
That's the only makeup I use because it's powder and foundation in one.
Wow, much wow.
So it's just and so I have like the pad, like where I get like the corners of my eyes, and then I have the brush. I have a brush to get the dome up here. That and shine sheets, so oil blotter sheets.
Do you oil blot the top of the head too?
Yeah, of course, because that's like maximum shine right there. It like looks like I'm glowing, like I'm a living exclamation point. And so Yeah, it goes up here, it goes on the cheeks, gets the T-zone, the whole deal. So that is my combos, is CoverGirl Ready Set Gorgeous. I should do a makeup tutorial on YouTube.
You really should. You really should. I had a lot of people saying like he looks so great because we just tuned to it because it's streamed on YouTube.
Oh, very cool.
Yeah, just like live. So if ever I'm just, like, hey guys, I don't have a topic today. We're just going to watch some of this. And then you pop up. I don't know how many. We're like, Dr. Paul's
that's
here.
All I do. They take all the clips where I'm going,
and then they say they need more energy.
Joke.
Don't forget Natural Beauty. I also shop at Forever 21. He's not about to drop those secrets just yet. So Graham asks, are you going to talk to us from the boat next week? Because you're going to be on a boat.
I'm going to be on a boat. I probably will not, sadly, because the internet is too unreliable for streaming.
Yeah. Yeah.
Wah, wah.
But it'll be cool for everybody that's going. And there's a whole thing where they offer these star cruises or star trips. They're not always cruises. And that's Astro Tours. Astro Tours
Astrotours.co. We are
.co.
signing up trips. Oh, check this out.
What?
We've got Ethan Siegel going to Iceland in January. We've got Fraser King going to Costa Rica in March. We have Dean Regas going to Ireland in May. We have Sarah El Shafia, paleontologist, going on a fossil trek in June. We just announced Pamela Gay leading a trip to Arizona next August. All those trips are open for booking right now.
Yeah, so people like you guys can go and do that if you want to.
Which you should. And we're putting something together, a very special, this is not on the books yet, it is not official. So I could be wrong about all of it because we're waiting on a couple more contracts and might fall through. We're putting together an all-stars party.
Am I going to be
Joshua Tree outside of LA?
Am I an all-star?
You might be an all-star.
Maybe. If that whole thing even happens.
If it even happens, you might get a little invitation in your inbox.
Oh my goodness. I'm an all-star. Joshua Tree is great for observing the night sky.
Gorgeous.
So perfect.
We have the resort picked out and contracted. What we're working on now is the motor coach to get us from the resort to the middle of the desert every night.
Get your game on, go play. Yeah, though I know a photographer that lives there. There's a lot of astrophotography happens in Joshua Tree. Oh
yeah, because there's a lot of people in LA. And Joshua Tree is like right there.
Right. Yeah. The whole Bermuda Triangle thing is a big myth from the internet. I don't know where that came from, Woo-Roo. No idea.
Just dropping pearls.
Just that wisdom. So yeah, today, you know what we've been talking about so far?
Tell me.
Juno.
Juno what?
Juno. Oh man, hey-oh.
Hey-oh.
Yeah. So,
that's right.
Oh my God. I ran into that one. So yeah, the Juno mission and how Jupiter. So I've asked you about Jupiter, and a lot of people are like, "Hey,
Jupiter's cool."
Yeah, and you're like, "Well, you could kind of hate and love it, right?"
One way or the other. All this month on my Instagram, I'm posting JunoCam images. Have you browsed those galleries?
Well, yeah, I have an image right behind us of one of the JunoCam images. Yeah.
Very cool. Like, because they put out the raw data and then they let other people process it and either make it scientifically accurate or turn it into art. And so there's all these wonderful galleries.
Yeah.
And so I'm pulling from that all month on Instagram.
Yeah. And that, I mean, there's been some really cool stuff that's come out with JunoCam, but it's something that everybody can do. If you guys like tweaking photos and having fun with them, you can do whatever you want from the information that they're getting from Juno.
Yep, and then you just post it online, and people take that and do whatever, like post it to Instagram, like I do.
Have it as their background when doing an interview with Dr. Paul, like I do. Yeah, so Jupiter, and one of the things that people talk about a lot that I'm curious to see what you think about it, even though we don't really know, we don't have conclusive stuff. With its core, do you think that it has a core?
It seems likely, which is like the most confident thing I can say, about this, that it does have some sort of rocky core. When you just look at the composition of the solar system and how planets are made and how planets form, it seems very likely that there are some really heavy stuff. Maybe something like the size of the Earth, maybe a little bit bigger, rocky. And then you get into almost immediately the bulk of Jupiter, the interior layers are made of a very, very strange substance we call metallic hydrogen.
Yeah, and how do you make metallic hydrogen?
Step one, take hydrogen.
Okay.
You with me so far?
Got it.
Okay. Step two, squeeze it.
Okay.
There is no step three.
So it's just pressure.
It's just pressure. It's just hydrogen under pressure. It turns out that hydrogen under high pressure behaves weird.
Yeah, and so do we get any kind of magnetic or electric stuff going on when you have that kind of pressure?
Yeah, so Jupiter has, outside the sun, Jupiter has by far the strongest magnetic fields in the solar system. Incredibly dangerous environment around Jupiter because of these strong magnetic fields and their ability to capture charged particles and channel them. And something is creating that strong magnetic field. In order to create a strong magnetic field like that, you need charged particles moving around really fast. So there must be inside of Jupiter charged particles moving around really fast.
Well, I mean, its atmosphere moves around really fast too, though, right?
Its atmosphere does whip around really fast.
The winds.
But the winds are very, very fast. But there is some sort of a churning going on. Let's use that word. Just like on the Earth, we have winds on the surface that whip around kind of fast, sometimes faster than normal. But then we also have a core with iron and nickel that is spinning really rapidly and generating our magnetic field. So where does Jupiter's magnetic field originate? Does it originate in the core, in this metallic hydrogen layer, somewhere else? We don't fully know, which is one of the reasons that Jupiter or Juno probe is so focused on the magnetic field, because you understand the magnetic field, you understand the interior of Jupiter.
Yeah, and someone actually in the comments, so Fenring said, what about the team of scientists that claimed they created metallic hydrogen in a diamond anvil, but then lost the sample?
Yeah, this is such a hilarious story. Like, we're pretty sure metallic hydrogen exists. When you look at the phase diagrams and the mathematics of how, and you understand the forces that of how hydrogen behaves with itself and with its friends and neighbors under high pressure, you're like, yeah, there's metallic hydrogen is a thing. But it's very, very difficult to make because you need a lot of pressure, significantly more than average pressure. So experimentalists have come up with these contraptions like diamond-tipped anvils that can reach, I don't know, like millions or billions of times sea pressure, and put little bits of hydrogen in there and squeeze it down. And the cool thing about metallic hydrogen, and this is one of my favorite words in all of physics, is that it's metastable.
Metastable. That's your favorite.
Not stable, not unstable, metastable. One of my favorite. I have like a top 5. It's in the top 5.
Why that one? Why is that one in the top 5?
It's a cool word. I mean, how many times in your life have you dropped the word metastable?
All the time with my Twitch chat.
Don't lie to me.
Okay, so never.
See? That's what I thought.
My Twitch chat is metastable.
Yeah.
Yeah, what are some other ones that you like? Other words?
Some other 4-letter words? No, other 4 words.
Other 4 words.
So I really like Gedanken experiment.
Wow.
That means thought experiment. It's German for thought experiment. It turns out most of my favorite words are German. I really like Bremsstrahlung. Bremsstrahlung is a kind of radiation.
Now these are different languages. These don't count.
Now other languages have words. and they're allowed to be your favorite word. We did not say, Paul, what's your favorite English language word used in science? No.
I didn't narrow it down. Yeah, this is true. This is true.
I like the word causal because I always end up typing casual, and it makes my sentences really funny until I find the typo.
Yeah, it's like defiantly versus definitely.
Yes.
Yeah. Defiantly causal.
Yeah, so Gedanken experiment, Bremsstrahlung, causal, metastable. There's a couple others. Probably a couple others.
Hydrostatic equilibrium.
Meh.
No?
That's a nice little phrase. It's a nice phrase. It's not my top 5, though.
Okay.
There have to be winners and losers, all right?
Okay.
Pancake. Mr. Mayhem's favorite word is pancake. In cosmology, there's something called a Zeldovich pancake.
I don't even... Really?
A Zeldovich pancake.
What does that mean?
A Zeldovich pancake. Zeldovich was a Russian or Soviet scientist, physicist, cosmologist, super smart guy. Heyday was like the 40s, 50s, 60s, and 70s. Did so much work, and barely anyone knows about him, even though he was so impactful in the field. And he was studying the problem of the growth of large structures in the universe. Like, how do you build galaxies and galaxy clusters? And back in the day, there were two debates. Like, do you build big things in our universe by starting with small bits and gluing them together? Or does the universe start off with big bits and then it fractures into smaller bits? And in this picture, in the fracturing, if you take a big ball of gas or whatever, and it's going to contract in on itself through gravity, it won't do so all dimensions equally because there'll be little bumps and wiggles and irregularities. So one dimension will collapse before the others, and it will pancake.
Oh.
You'll get a Zeldovich pancake.
Oh, sounds tasty. Sort of.
Very fluffy.
Very
have
fluffy.
You seen those Japanese pancakes? They're almost like souffles. Like,
yeah.
It's like that. It's very tasty. And made of galaxies.
Oh, great. Even better. So what pressure is needed for metallic hydrogen? Is it comparable to pressure needed for electron degeneracy? It's probably much less, right? That's what somebody
So
asked.
I don't know the number off the top of my head. I think it's like 1 billion times sea pressure if I remember right, but don't quote me on that. And someone's going to quote me on that. And so metallic hydrogen is how should I say this? It's not quite the densities and pressures of something like a white dwarf, but Jupiter is supported by degeneracy pressure through its metallic hydrogen. You get degeneracy pressure effects with metallic hydrogen.
Because the electrons don't want to touch?
Because the electrons more than don't want to touch. Like, if you have two electrons, they have the exact same charge. They don't want to be close together.
Right. No.
But you can squeeze them down. As long as you have enough force, you can get them smaller, closer and closer and closer and closer together.
Right.
Until a new source of resistance pops up, a very quantum and exotic source of resistance, where you squeeze them, and they say, no, not doing that. That is what's called degeneracy pressure.
Right.
And something like a white dwarf star is fully supported, 100% supported by degeneracy pressure. Jupiter, I think, is 50%, half supported by degeneracy pressure and half supported by other things.
Interesting. Huh. I didn't know that. I actually did not know that. But I mean, I knew that it does have these layers of, these charged particles and so we have to take them to jail. Wait, what? What are we talking about? Have you heard of the quantized inertia, QI? Dr. McCullough has recently a grant from DARPA.
Okay. I can get into that.
Yeah.
By the way, the sun, there's a little bit of degeneracy pressure supporting the sun. It's like 5%, 10% supported by degeneracy pressure. True story.
Just feeling its future.
Yeah, and it has metastable. I never finished metastable. Metastable means it will exist as long as you don't bug it. If you don't
Okay.
like shake it or breathe on it or do something, it can hang out.
So like
But
inertia.
it's something like inertia. It's something like the analogy I like to use is that if you're skiing down a hill and you get caught on a rock, you're there. As long as you don't move, you're there, stuck halfway down the hill. But if someone shakes you or pushes you, you'll fall off the rock and then you'll go all the way down to the bottom.
I feel like that's great with inertia. Just don't mess with it. It either wants to stay in a state of rest or it wants to keep going.
Mess with the metastable state.
Right.
And so the researchers claim they made a sample of metallic hydrogen. Metallic hydrogen is metastable, which means if you don't breathe on it, it'll just hang out there and you can look at it, but don't touch. Like someone touched it. Like they came in the lab the next day and it was gone. Now, did they really make metallic hydrogen or not? That's up for debate. That's not my game.
Oh man. I was thinking of the Pauli exclusion principle. Those are both of degeneracy pressure.
Yes. Degeneracy pressure follows from the Pauli exclusion principle.
It does. So back to that quantized inertia, which I'm sorry guys.
Quantized inertia is nonsense.
Yeah, I don't even know what this is.
It's like, so this concept of inertia, which you brought up, which is objects in motion tend to stay in motion, objects at rest tend to stay at rest. It takes a certain amount of oomph for to make an object change its state. The amount of oomph is what we call inertia. More massive objects have more inertia, for example. Faster moving objects have more inertia. They're harder to stop. And so, Mike McCullough is a crackpot who in this idea makes no sense at all and is not mathematically rigorous or physically sound. But that doesn't stop him from spamming my Twitter so much that I had to mute him or ban him or do whatever. And then he has a bunch of sock puppet accounts that he use, like, why'd you ban Mike McCullough? You're not a real scientist. You're not critical. And so it's like,
yep, I get those all the time. All the time. Yep.
Ban.
Block.
I ban people on YouTube. I hate banning people, but it's like, no, this isn't a forum for your crackpot theories, especially when it's 2,000 links.
Right. They're never short.
It's not a forum for saying hateful things.
Right. It's either these long-winded responses or just these really short to the chase, like nasty things.
Both.
You can have both.
It's stuff like it's just ban. I ban it all.
Yeah, I don't usually have both. I usually just have either or, but I'm sure that both can exist, and I will see that.
Both exist. I get a long email about once or twice, once every day or two, with, I have a theory of how things work. Can you please look it over? I get a physical letter in my P.O. box about once a week.
Oh, nice.
With, handwritten, the whole deal. Don't read any of it.
Yeah.
Sorry. If you're out there, you've got your own theory. That's great. You need to submit it to a journal and have it accepted by the editorial board and a referee, just like all of us. If you want to play the game, I don't send my paper out to some random department and say, could you please look this over? No, I submit it to a journal.
No, you actually say, hey, can you please look this over? I've been on How the Universe Works.
Dear sir or madam, I have a revolutionary new theory of gravitarnos that I believe unlocks all of quantum Physics. Gravitarnos.
Gravitarnos. Dear beloved. Exactly.
Dear beloved, may I beseech thee for a moment of your kindly embrace to consider my request of the Gravitarno.
Perfect. That's great. We are gathered here for the Gravitardo.
You may wonder why I have summoned you to read this email message.
I'm like crying. I'm laughing too hard. But he gets exposure for a bad theory. Bummer. That happens a lot. So
promoters are gonna promote.
Yeah.
They're gonna do their thing. And so it's very challenging where, you know, I'm trying to spread science communication. Yes, there's a lot we don't know about the universe, but here's what we do know, and here's how we know it, and here's how we're figuring out the stuff we don't know. And then there's like scads of YouTube videos of just guy with a camera and a bunch of B-roll making stuff up. And I'm not really like, I don't see it as like competition, like, oh, they're getting all the views, but it's just like, it's making my job harder.
Well, yeah. Yeah, no, it does. When there's, yeah, I mean, to a sense, to a degree, it is competition to a degree, but I mean
they are taking my ad revenue and clicks and views and subs and live notifications.
Yeah, with just bad science, it happens a lot. On this platform, I don't have bad science to compete against, but I got other demons. Snake
You're
oil.
battling your own. You have your own battles.
I got my own. Can you explain?
That meth ain't gonna smoke itself.
Can you explain to movie makers why you can't just run things into the sun?
It's actually really hard to go to the sun.
Yeah, we've been Parker Probe is showing that.
It's like it takes forever because we here on Earth are going super fast, tens of thousands of miles per hour. If something leaves the Earth, it's going at tens of thousands of miles per hour around the sun. The sun is going 0. So you have to change by tens of thousands of miles per hour. And slowing down by tens of thousands of miles per hour is just as hard as speeding up by tens of thousands of miles per hour.
Yeah. Yeah.
It's going to take a while.
Yep. So people were asking if we sent like something to Jupiter, like a device that would detonate, like, because, you know, people get really concerned about Jupiter not being a star, and everybody says it wanted to be a star, but I would like to say it's a doubly failed star rather than just saying a failed star. I feel like it doubly failed. Well, you know,
that's harsh.
Well, you know, it's not.
That's harsh.
It's not a
I'm
brown
glad
dwarf.
I'm not your child.
You know,
you're not just a failure. You're a double failure.
You gotta let him know.
You failed at failing.
Yeah. Well, you can't go light with it, right? So I mean, it's not a brown dwarf star, right? It's not.
Jupiter is not a brown dwarf. You need definitions here get a little bit fuzzy because we don't fully understand the physics. Generally accepted, somewhere around 12 times the mass of Jupiter gets you into the brown dwarf club.
Yeah, right. And this guy would need 80 times its own mass to become a star. So if we say 12, just because of what we understand today for a brown dwarf, see, that's doubly failed.
Doubly failed. So am I, as a human being, I am not an asteroid, not a dwarf planet, not a giant planet, not a brown dwarf, not a red dwarf star, not a main sequence star, not a supergiant. I am octuple failure.
Yeah.
As a human being.
Yeah, we'll just say you're a small portion of the ordinary matter, you know.
That
doubly failed.
Octuply failed.
Octuply failed. Leave Jupiter alone.
I'm a degenerate, though.
We can send some monoliths. That'll light it right up. Well, that's what people are asking. Like, can we? Because, you know, this all comes from the movie Sunshine. I'm pretty sure this is where this comes from. Can we send a payload to Jupiter or the sun?
Oh,
you know, and reignite it or ignite it. Which the sun doesn't have any problems with reignition. It's doing fine.
The sun is rather preoccupied.
Right. The sun's
being a giant nuclear bomb right now.
Right. It's totally fine. Go appreciate that thing in the daytime if it's daytime where you are.
Don't look at it.
Don't look at it. Wear sunscreen.
Are gonna do that. Some of you are gonna like, I appreciate you. Why are you burning my
eyes? But then you have something like Jupiter, right? Which, you know, sends out more energy than it receives from the sun.
Yeah.
Right. And it's got a lot of hydrogen. It's got
selfless.
Yeah, it's got a lot of helium too, which is, something that our sun does, about 24% helium. And then it's got, like 1% of miscellaneous things like carbon, nitrogen, ammonia. Other, right.
Which in astronomy jargon, there are only 3 elements in the universe.
3? I thought there was only 2.
There's hydrogen, helium, and other.
Oh, okay.
And the others is what we call metals.
Metals, right. So people are asking, can we do this with Jupiter? Could we make it a brown dwarf?
No.
No? Did you just kill the dreams of everybody who loved the movie Sunshine?
I'm letting that sink in. No.
I'm going to just go ahead and say why not. Just going to ask for the crowd.
Because I said so. Isn't it hot enough in the summer, folks? Want another star here? So in order to make Jupiter a brown dwarf, which isn't really a star or a planet, brown dwarfs are their own thing. Actually, funny you ask, I have an episode coming up on it next month on the podcast and YouTube series, all about brown dwarfs being weird.
Good. We'll watch those.
Thematically inspired because I finally watched Freaks and Geeks. And so I felt like brown dwarfs were the freaks of the high school.
Mm-hmm. Absolutely.
And if in order to make that, you need at least a mass of 12 times that of Jupiter. Right. So we've got 1 Jupiter in the solar system. Check. You need 11 other Jupiters to ignite it.
Right.
11 other Jupiters.
Mm-hmm.
Jupiter is by far the most massive planet. You could throw Saturn in, and Neptune, and Uranus, and all the rocky planets, and all the asteroids, and you have something like 1.5 Jupiters tops. Okay, so you got 10.5 to go there, champ.
All right.
You'd have to steal material from the sun itself, cart it out there, dump it on Jupiter. And really all you have to do is just pour it on. Just pour on the gas, layer after layer after layer. You're going to have to wait probably 1 million years or so, because that process of dumping all the gas on is going to generate a lot of heat. It'll take a lot of time for that heat to radiate out so the gas can compress and form a centralized object again, a compact object. Okay, so yes, you can do it, but you have to steal from the sun.
You have to steal from the sun.
You have to steal from the sun 11 Jupiters worth of stuff from the sun. You have to scoop it out.
I don't feel like the sun's going to let us do that.
The sun is not very friendly. The sun will melt your face, which I don't know if I've ever told you this story. So about melting your faces. So during the Great American Eclipse last August, I co-hosted on the Weather Channel. I was on the Weather Channel all day long.
Mm-hmm.
But all day I kept getting texts about and like emails saying, I saw you on the Colbert Report. I was like, I'm on the Weather Channel, not like where. And I finally, after I looked it up, and the Colbert Report did a thing where they pulled clips from all the local news stations of people warning their audiences not to look directly at the sun. So it's this big montage of don't look at the sun, don't look at the sun. And I was one of the clips saying, it will melt your face off.
Oh my God. Wow.
It's there.
It's
there. All day. I'm like, I'm live on the Weather Channel. And they're like, I don't care. I saw you on Colbert Report last night.
Wow. God. Let's see here. I'm sorry. I was reading chat too. So as soon as the sun bloats up to a red giant, what are the chances of Jupiter stealing the sun's mass then?
Oh, yeah. So when the sun dies, it's going to get really tricky. It's going to get really complicated. Jupiter and the sun already have a very complicated relationship.
Mm-hmm.
And it's just going to get really dicey as the sun dies, because the sun is going to expand and contract and expand and contract. It'll go through a bunch of cycles.
Right.
And with every cycle, it'll eject layers of its own material out into the solar system. This is going to destabilize our solar system.
Mm-hmm. So
some planets are going to get eaten alive. Mercury and Venus, gone.
Right.
Earth seems right on the edge of where the sun will be, red giant. So, 50-50 shot. We'll be
Right.
cooked alive. We'll be cooked, but whether we'll be eaten alive or not is another question.
Right.
And the outer planets might migrate outwards. They might become detached altogether. They might survive this red giant phase. And during that red giant phase, all this material will be blasting out. Jupiter, because it's so far away from the sun, it will catch a little bit of it, like
Right.
a little bit of the barf will hit Jupiter's face, but only a tiny bit because Jupiter is really small and it's way out here compared to the sun. So it will, if it survives, it will gain in mass, but not a lot.
Yeah, and it also has that magnetic field, though, right? That protects it as well.
It also has the magnetic field. So if you're a it depends on how quickly the charged particles are hitting you,
right,
of what your magnetic field will do. If you're a very slow charged particle, you'll just bounce off. If you're a medium one, you'll get caught up in the magnetic fields and then dumped into the poles. And if you're fast, you'll just slam right through it.
So that's where we get our nice, lovely auroras, is because it gets dumped into the poles.
Yeah, we get the aurora from the medium ones, and then when we get hit with a flare or a coronal mass ejection, that's when we get like really massive light ups, even at southern latitudes.
Yeah. So when the sun dies, we're all screwed. So yes. It will be a little bit before then, right? The sun's going to be getting bigger. Hotter. It will more luminous, I guess you would say. It's actually going to be cooling down.
Yeah. It'll be brighter.
It'll be brighter.
So the sun is slowly getting brighter with time. This is nothing to do with climate change. We're talking over the course of hundreds of millions of years. So the dinosaurs knew a slightly dimmer sun. And in like 300-400 million years, our oceans will boil.
Yeah.
So it's really, life has been on Earth for 3 billion years. We're actually towards the tail end of life being able to flourish on the Earth. After the oceans boil, there might be like little pockets, like subterranean regions, little craters here and there, maybe the polar regions, where some form of life might cling to the planet. But life flourishing on the Earth, we're already in the last chapter.
Yeah. And someone says, so as it gets brighter, would it shorten our days?
So it's our rotation isn't going to change much. So the length of the days will stay the same. It's just going to be really hot out. And our moon, coincidentally, is also slowly moving further away as it ages. So our sun is slowly getting bigger, and the moon is slowly getting further away. So eventually, around that same time frame, total eclipses will become impossible because the moon won't be able to cover up the sun anymore. So when the eclipses stop, it's time to get out.
It's a good sign to leave. We call those moon charts.
Yes, moon signs.
No, but so that's a good point too. We haven't really even talked about it that much further. But so the sun is going to swell up. We don't know if it's going to engulf Earth. It has a potential. So while it's actually getting bigger, which a lot of people think that size is equal to mass, it's losing mass.
Right.
So it's gravitational
bigger,
influence.
It's getting fatter, but not heavier.
Right. So its gravitational influence as being like the bowling ball in the middle of our trampoline solar system is becoming weakened, right? Over time.
So yes, so the sun is very slowly losing mass for a few reasons. One is the nuclear reactions happening in its core that turn hydrogen into helium. That leaves behind a little bit of mass in the form of energy because E equals mc squared. So as it burns, it's slowly losing mass. And then also from the surface, it's constantly ejecting this rain of solar wind, of charged particles, and it's losing mass through its surface, through its hot surface. These, as far as I know, aren't really that much. What's what's going to be the big thing during the red giant phase is just the sun is going to get larger. It will have a slightly lower mass than it does today, but the main thing is it's going to be much, much bigger.
Yeah, much bigger. And that solar wind is going to be blown out more and more luminous. It doesn't sound like a place you want to be.
When our sun enters this phase and creates what's called a planetary nebula, it is one of the most dangerous times to be around a star, especially towards the final stages, because there's these repeated cycles of inflation and then collapse, inflation and collapse. And then after enough of these cycles, the entire solar atmosphere, like most of the sun, gets ejected or detached and starts floating out. But the core remains, and the core of our sun has like a temperature of 1,000,000 degrees.
Right.
And when the sun loses its outer layers, you just have a furnace in the middle that is spitting out X-rays like crazy. And so if you were there, you would be blasted by X-rays, and from that remaining core, and then that core will take like 10,000 years to cool off.
Right.
Before it won't be dangerous anymore.
So what if I just like dress myself in a lead suit?
Okay.
I mean,
fine. So that you can stay in orbit around our dead sun.
Yes, please. I mean, these are big ideas.
In a lead suit.
Yeah, well, you know, protect the woman bits, you know, just make sure that all of that's good, you know, like if I'm getting an X-ray, I just want to make sure I'm not getting a heavy dose of that radiation. So I'm just going to, but this time I'll suit up everything, you know, just for good measure.
Just the woman bits.
The ovaries, all right?
Ovaries. So it'd be like a lead girdle.
It's like that heavy apron they put on you when you get dental X-rays. Do you guys have to get that too?
Are you concerned about your ovaries when you get dental X-rays?
They apparently are. They apparently are. They are so concerned. They're like, here's this heavy vest and weighs more than me. And
for the ovaries.
For the ovaries. Hashtag.
Why is it around my neck? Don't ask questions. I'm the doctor here.
No, it's like a full like blacksmith apron of just
lead. No, I know exactly. So just snag one of those the next time you're at the dentist, so that in 4.5 billion years, when our sun dies, you can keep the human race going.
Right, exactly. And there's men parts too. For our universe or underverse.
So
wait,
off the rails.
I know. Lead chastity belt. No, but this is X-ray radiation doesn't penetrate through lead.
Anti-chastity belt.
Right. Right.
Yeah.
It's surprising that white dwarfs would cool off in about 10,000 years. Seems very quick. It does.
Yes, you're right.
Seems very fast.
10,000 years. It's because they're so hot and they're not generating heat anymore. So they stay hot like for trillions of years, but only X-ray hot for about 10,000. But we see planetary nebula all over the place because planetary nebula are formed from stars like our sun. Stars like our sun are very common. So even though each one only lasts for 10,000 years, they're constantly popping up all over the galaxy. So if you waited 10,000 years, or if you brought a telescope back 10,000 years ago, they would have a different set of planetary nebula visible to them than we do to us.
So do we have any kind of ideas of what shape our planetary nebula will take?
No clue at all. This is a very complex, very chaotic process that depends on a lot of things. And if you look out at planetary nebula, they have like all sorts of shapes.
They look different, all of them, yeah.
Every single one, they're like little Christmas ornaments.
Yeah, exactly. They do.
So who knows? Who knows what our sun will do?
Yeah. Let's see here. Yeah, because I didn't know it was about 10,000 years. I thought that they would go on shining super bright, but we do have. So then if it's only 10,000 years, then we would have to be able to have remnants of these black dwarves, which are essentially just the burnt out cores, right?
Right. So let me clarify. Again, it's 10,000 years roughly. For a white dwarf to be hot enough to emit X-rays, you need tons of energy, tons of heat. So we're talking millions of degrees to make the X-rays. After about 10,000 years, it cools down to be merely hundreds of thousands or thousands of degrees, where it's instead giving off visible light or ultraviolet light or infrared light. That cool down time takes billions or trillions of years.
Okay. There we go.
So it's 10,000 years to be up here in the X-rays, but then very quickly they shut off their X-rays. When the X-rays shut off, that's when the planetary nebula shuts off because that's what illuminates it. And then it just slinks down cooler and cooler and cooler. That takes like trillions of years.
Got it. Yeah, because I don't think we've
Sorry about the confusion.
No. So I don't think we found a black dwarf, have we?
No. There hasn't been enough time in our universe to make a black dwarf yet.
Perfect.
There are brown dwarfs that are really, really, really cold, like literally room temperature. Like you could go swimming in them.
Right, but that wouldn't be great to sustain life.
I mean, it's also poisonous, but whatever. It'd feel good.
It's like tanning.
Like, this is nice. This is nice. You'd be crushed by the extreme gravity too, but you're like, this is nice.
Right. I feel like people do that a lot.
So we have those.
Earth.
We have brown dwarfs that are very, very dim and dark, but no white dwarfs have cooled down to be black dwarfs, which is why brown dwarfs are called brown dwarfs, by the way. When we first figured out that this object might exist, the first name suggested was black dwarf because they don't hardly glow in visible light at all. But then someone pointed out that black dwarf is already taken as the end state of a white dwarf. And even though black dwarfs don't exist in our universe yet, they already called dibs on the name. And so we went with brown dwarf.
Someone's just like question marks. I think they were wondering about my tanning comment. What I was saying is like you wouldn't want to. Okay. I was saying it feels good, but you're really actually hurting yourself. It's, same thing with like swimming on a brown dwarf. Like it might feel good, but it's just a little poisonous.
Like cigarettes.
Right. So there's the bridge there. It's like, but do we know of any of these brown dwarf stars like that they're cooling off from a state of being a white dwarf, or do we see them being like the part of a solar system that was created and that's just what all they got? That's all the matter they got and that's what they're doing with it?
Yeah, so we're not exactly sure how brown dwarfs form. There are a few proposed mechanisms out there, but we don't know of a lot of brown dwarfs, like a few hundred tops, because they're so hard to spot, because they're small and they're dim and they're far away. And brown dwarfs could be like, this is all the matter you're going to get to form, and you only have enough stuff to make a brown dwarf, and so you don't get to make a star. Or they could more generally form as part of multiple systems where they get ejected before they have a chance to agglomerate a lot of material. Seems to be a little bit of both. It's hard to tell which is the dominant mechanism.
Yeah. Okay. And they're probably, like you said, super hard to detect because we have a hard time with red dwarf stars, which are fusing stars. Yeah. And they're just...
If you go out to if you look at the night sky, the most distant star is, what is it, 2,000 light years away?
Yeah.
That you can see with the naked eye, somewhere around there. And then there's total 6,000 stars you can see, roughly, with the naked eye in the night sky. But in that same bubble, that 2,000 light year bubble, there are 1 million stars.
Yeah. And Tess, did you see the photo of Tess that Tess sent back?
No, I'm looking it up right now.
Yeah, it was actually, I tweeted it. I retweeted it. It's pretty cool.
I was on Twitter.
I know.
So I looked up, I Google searched Tess photo, and not getting what I intended.
No. I'd be wary.
News. I'll go to news. Here we go. Oh, that's pretty.
Pretty cool, you mean?
It's pretty. The LMG.
Yeah. I'm going to show everybody here. Yeah. This is Tess. Tess took this.
Test.
Which this star right here is super bright. So bright that it did this to the image. But there's the Large Magellanic Cloud over here. And that, yeah, the star totally photobombed it. Like, actually photobombed it. But this is looking at Tess is looking at something that's, nearby stars and the exoplanets that are transiting those and other things. It's doing other miscellaneous science too. It's going to be really cool to see what kind of proposals come in, like, as far as anything other than exoplanet research, what they're going to use this guy for. I think they're using him for a bunch of other stuff, but her. Okay.
Tess.
All right. Fine. But look at how many stars there are.
It's full of stars.
Well, this is what's crazy is you don't really.
There's lots of stars out there. Just take binoculars, and point the binoculars at a blank patch of sky. You'll see stars all over the place.
Mm-hmm. Yeah, these are a lot of stars. But I'm so excited for this stuff to send more information back. And they even, I think right here, yeah, they have the. Did you see this one? I don't know if you can actually see my screen or not, but
I'm not paying attention to your stream.
Great.
I'll pull it up.
For that, I'm making your cam slightly smaller just so we can capture it. Because it shows the Large Magellanic Cloud.
Why am I below you?
You're not below me.
I'm like, yeah, I'm below you.
You're off to here?
I'm over to the side, which I'm okay with. But I'm not an equal to you.
Okay, here. Is that better? We're just gonna
just
fine.
No, too far. Down, bring it down.
I don't know. Wait. How's that? That might be good. I just wanted to show the Large and Small Magellanic Cloud, Dr. Paul.
Are you cross-eyed? Like this is not even.
No, it's not even at all.
This is bugging me now.
Well, geez. Well, hold on. If I need it to be even, well, God, no, this is like way hard to do with my cam too. It doesn't want to set it even.
Don't move it. No, you moved it. It was just fine.
Damn it. Hold on. That's better. Maybe? No.
I'm still smaller.
Okay, well, that's just because we're looking at something over here on the side, here.
Fine.
Just for a second. Okay.
Just say what you were going to say.
That's the Small Magellanic Cloud. That's the Large Magellanic Cloud. That's all.
Oh.
Mm-hmm.
I could just told you that.
But people can see it from Tess.
Make me big again.
Okay. You're bigger now. See? We got the boxes. Speaking of which,
someone's saying I should change my camera angle. I got a lot of negative space. You have a lot of negative space.
Your face is a lot of negative space.
Making it worse, I think.
We can do the giveaway now for.
Let's do the giveaway.
Yeah. So we can do the giveaway for the telescope, and yep.
Before we do the giveaway, sign up to my Patreon.com/PM Sutter. If you contribute at least $10 a month for the next 3 months, I'm giving you a free autographed copy of my book.
And he has a book, by the way, guys. We're going to get to that at the end.
Coming out November 20th.
Yeah. Don't
read the Amazon reviews. It's very good, I promise.
Look at that smile.
I promise. It's so. I worked really hard on it, guys.
He's about to cry over that telescope. So little do you guys know, it's going to be autographed with Dr. Paul's tears.
My salty tears from the nasty people on Amazon Vine.
Yeah. So Dr.
Got
Paul
pre-release copies and did not like my book.
We have to get a keyword from you. Give us a keyword for subs to. I'm going to put it in sub only mode.
Patreon.com/PM Sutter.
No, that's a hell of a keyword.
Metastable.
Oh man. Okay. Metastable. That's going to be the keyword, and I'll tell you when to go. Joe will actually tell everybody when to go on that. Well, people are going to. Yeah, you have to wait. Joe has to boot it up. So Just so you did ship that out to Amber. Amber is going to be getting hers. Can we play?
It's on her way. It's on the way.
Yeah.
A couple days.
Mm-hmm. Okay.
This one, it'll be a couple weeks because I'm going on the Astrotour cruise this Thursday. And if I can't get it out soon, I will. If not, it'll be a few weeks.
There we go. You don't need an exclamation point at all. No, just type metastable. It's for EU and NA. There's no restriction there. So just type the word metastable. That's literally it. No exclamation point. None. Not needed. And while they're doing this, so the radiation, don't drop it. So
I got it. Two-hand hold.
So the radiation from Jupiter is really, really heavy and crazy and insane. What does it do to the moons?
It's not necessarily from Jupiter.
Okay.
So Jupiter does emit some charged particles, but also there's lots of charged particles constantly streaming out of the sun.
Right.
And they get trapped in Jupiter's magnetic field, which makes that environment really crazy.
So it affects the moons, though, right? And the rings, like it's sending out that.
Oh, yeah. So this radiation is constantly blasting down onto the surface of Europa and Ganymede. Io's a madhouse, but it's a madhouse anyway. Just the near Jupiter environment is much, much nastier than the environment around, say, Saturn.
Mm-hmm. Yeah, no, Joe. It's just an encouraging thing. And also, again, since he's able to do that, I'm going to say we do another like 5 minutes, or not 5 minutes, wow, 5 seconds. And then, Joe, you can roll it.
Then, right, there is a large current going between Jupiter and Io.
Yeah. And so that's what causes, you probably just said it, that's what causes a lot of the volcanism.
Yes. So Io's ejecting charged particles. It's also really close to Jupiter. It's just nasty.
Dodgy won something.
Dodgy blaster.
Dodgy actually won something. He's been around for forever. Yeah, Dodgy actually won something. Rigged. And then he always gets timed out.
I'll stop clapping now.
Awesome. Dodgy, if you want to send me the information, I'll send that over to Paul.
And you will eventually
get one of
get
those.
This telescope. Do you want it autographed? I autographed Amanda's one.
I would say do it.
Like the side of the barrel.
I would do it.
Okay, I'll do it.
Yeah. Well, yes, please, he says.
All right, you got it.
I
will draw something inappropriate on your telescope.
Perfect. Well, thank you so much. Appreciate all of that and being
Thank you.
able.
So much fun as always. Your Skynet. It's always a blast to talk to, and it'll be a couple weeks.
Yeah. So I'll talk to you soon.
With a tan.
With a tan. That's right. All right. Well, take care of yourself, and I will be in touch.
Astro tan.
Oh God.
Like one around a brown dwarf.
Oh goodness! Don't go swimming in it. All right.
Don't go. Okay. Take it easy.
See ya. Bye.